Hi everyone, welcome to your video on review of measurement theory. So in this video, most of the topics that I'm reviewing are going to be linked in the readings that you have next. And those readings they come from Neil Salkin's book, Tests and Measurement for People Who Think They Hate Tests and Measurement. And the reading is actually, I think, really easy, although it may look like kind of like a lot when you open it up. Salkin writes it in a way that for those who perhaps it's been a while since you've been in a statistics class or have thought about some of these mathematical measurement terms in such a way, in this way, he does a nice job of reintroducing that back in. So really basic he covers reliability, validity, and norms and percentiles. And these are all things that we need to consider when we're thinking about assessment and measurement, which is by nature this course too. So some of the measurement terms you need to know. Measurement here is best described as a procedure for assigning numbers to a specific attribute. Sometimes we will use interchangeably measurement and evaluation or measurement and assessment. But for here, primarily when we're talking about measurement, it's just that procedure for assigning numbers to that attribute, whether we're assigning it to intelligence or achievement or motivation or creativity. Evaluation, however, is the process of examining or judging the value or worth of such of those results. And another word that you're going to see, or term that you'll often see throughout the measures that you look at, whether it's the COGAT or the NNAT, etc. But you're going to see a standard error of measurement. And that's kind of like your buffer zone, right? That's giving you plus or minus some points or plus or minus some values in order to give you a really good understanding of probably where that student's creativity score may lie or where their IQ score may lie. So that standard error measurement is the estimation of the variation expected in the test results. And it is that idea of, while we may think that we can really capture someone's mathematical achievement with a single number, we know that single number doesn't really predict or isn't exactly what that student may know. So sometimes giving a standard error of measurement in order to give you at least a range, like plus or minus 3 points, may be helpful in saying that this is where the child may actually be. There are a lot of statistical procedures that go into figuring out what the standard error measurement is, and that you don't need to know. So you don't need to memorize any formulas or anything like that, but you do need to understand what the standard error of measurement is and what it represents. Another term you'll need to know is portfolios, and that's the systematic collection of student work selected to provide information about a student's attitude, motivation, level of development, and growth over time. That's often what we refer to when we talk about portfolio. All right, so let's move into reliability. So reliability is a term that we use when we're considering, I'm just going to use the word test here. We consider a test to be reliable when the student scores are within the same range on different versions of the same test. So reliable kind of being like dependable, or here another word that you can replace reliability with is consistency. So we want to make sure that there's consistency among scores. We want to talk about consistency among raters, so those who are scoring a test. We do a lot of that with when I train teachers for the Torrance test of creative thinking, because that is something that a machine can't do it. So we have to make sure that in certifying people to score, that if so-and-so scores and so-and-so scores and so-and-so scores and I score, that we all have final scores that are within that same little range, right? And then we also want consistency over time. So it's that idea that if I give a student, Form A of this achievement test, and I give a student over here Form B of that achievement test, we want those scores to be the same. And or if a student takes Form A and Form B, we expect their scores to be consistent across those forms. So reliability is about consistency. Reliability coefficients, you'll see those usually in the front end portion of all of your tests or assessments. Those reliability coefficients are calculated in a number of ways. We're not going to go into those calculations. That's beyond the scope of this class. But some general rules of thumb. You want to see test-retest reliability anywhere between 0.6 to 1. And that test-retest reliability is that idea that if I gave that child the same test or the same test that's also has been deemed reliable, would they get the same score? We want that to see that consistency. Inter-rater reliability, that's that 85, only 85, not 100%. It's impossible to do 100%. 85% agreement or a correlation of 0.8 or maybe 0.85. Some say that by rule of thumb, 0.7 is sufficient for inter-rater reliability. And again, you'll see all of these little numbers and terms in primarily in the assessment booklets, but that's kind of what that's referring to. You're not going to find assessments that are perfect, but so these are general rules of thumb. Internal consistency, that's you want all of the items that are within a test. You want all of those to be consistent with each other. And so you want to see an internal consistency coefficient of 0.7 or higher. And if you find a test that meets all these rules of thumb, it's 0.6 or higher for retest reliability, 0.8 or higher for interrelated reliability, or 0.7 for internal consistency, you've got a pretty good measure, a pretty solid measure. What you may find is some of the tests that districts use, they may be really good in one of these, but have lower scores in other of these areas, and that's where it just gets a little bit questionable as to how accurate or how consistent some of your scores are. Another thing that it's important to think about, because we're going to talk about validity soon, but high reliability. So if a test is really reliable, does not mean that it's necessarily high quality. So while it may meet all of those rules of thumb, you still make sure you want to be really careful that it's also valid, that it's also measuring what you are intending for it to measure. And we'll talk about validity in a few slides. So a few ways that you can increase reliability. Oftentimes that's by increasing the number of items that are on the test. Obviously, eliminating bad items is always a good idea. Standardizing the conditions or the instrument. So every time that this test or assessment is given, it's always in, it could even be like it's always in the lunchroom at this point in time, and these are the conditions in which it's tested. You want to have to moderate the degree of difficulty. You want to minimize the effect of internal events, which is anything that can minimize or distract from that testing environment, and you want to maintain consistent scoring procedures. So all of those are claimed to be ways to increase reliability, which a lot of those I think are really standard and kind of like duh, but it's important to make sure we remember what we can do to help increase our reliability. So validity, different concept. So reliability, consistency. Validity is about this idea of kind of answering that question, does my test or measure, does it do what it's intended to? Am I actually testing what I'm intending to test? So validity here is about accuracy. We say that a test is valid when it measures what the user wants it to measure. So if I'm creating, I just always use math, if I'm creating an Algebra 2 test on Unit 3, it will be valid if hopefully if all of the questions that are in there are talking about or cover concepts that we covered in that Unit 3. I'm not also including concepts from Unit 1 and Unit 2 if what I'm intending for it to measure is Unit 3. And we know that we can have these more cumulative like tests, in which case therefore our goal, our intention is likely not just a single unit or thing, but perhaps the whole course. So if it is a test valid? How do we know if a test is valid? How do we know that the COGAT actually measures mental ability and IQ, the intelligence quotient, what we think it's supposed to measure? Often with some of these big tests, these big measurements that are used across the board, they're nationally normed, etc. They refer to expert judges. They also look at results from similar measures. So in the creation of a new IQ test, what they will often do in those whole testing procedures to create the test is they will have someone take this IQ test, the new one, but also have them take one that's already been established to see if it's actually, to see if the results are fairly similar, is another way to kind of help prove that it's valid or that it's accurate. And again, ensuring that the test items reflect the trait that you are intending for it to measure. So from validity, there are also a few little sub-concepts of validity. We have content validity. So that's when we want the test items to sample the universe of items for which the test is designed. So that's that idea of within this test, is the content valid? Is the content accurate as to what I'm testing? So you can ask yourself, how well do the items on the test represent all possible items? Sometimes I find that, I'll go back and I'm like, I have,
12 questions from lesson 1 and 2 questions from lesson 2 and 1 question from lesson 3. I need to make sure if all of them have equal weight, that I have equal questions from each type of concept, right? How well do the number of items reflect the time spent teaching the topics being tested? And also ask yourself, is this type of validity, or this is the type of validity that's most often used for achievement tests? So kind of going through when you yourself create assessments, or when you're using some that you've adopted from others, going through to make sure that the content there, that it's valid. We also have criterion validity. So this assesses whether a test reflects a set of abilities in current or future setting as measured by another test. So we have often what we refer to as concurrent validity. So that's asking, how well does my test correlate with the outcomes of a similar test right now, like in 2018? We also have predictive validity. How well does my test predict performance on a similar measure in the future? Which this is where some of like the Torrance test for creative thinking has high predictive validity. That's kind of how it's been based. So when we see really high TTCT scores, it has, based on longitudinal data that people have collected from the TTCT over 50 to 60 years, that kids who score high are more likely to develop creative products or have creative positions, to be more actively creative in the future. So it has high predictive validity. There's also construct validity. So this is harder to assess because constructs cannot always be directly observed or measured. For example, aggression is a construct, hope, leadership, all of those are constructs. In which case we need to ask ourselves, when we're looking at construct validity, how can we look at how we expect other behaviors to correlate with a construct? So if I'm developing a measure to measure someone's ability to, let's say, be aggressive, then I'm also going to try to find a measure that looks like at the opposite of aggression, which might be like passivity or passiveness. I don't know what that word is. And so I would want those scores to be really different, right? If someone's high on aggression, I would expect them to be really low passive wise, or vice versa. If they were really low on that aggressive scale, I would therefore predict them to be high on that passive scale. So that's a way you can kind of create some construct validity. We also, you want to think about, you want our construct to correlate with related behaviors and not correlate with behaviors that are not related. So that was kind of that example that I just gave. Or for example, we would expect here a masculinity score to have a positive correlation with testosterone levels. So if I'm creating that measure to score masculinity, which is a construct, if I actually tested their testosterone levels, I would expect to see a high correlation. All right. So summary for reliability and validity. A test can be reliable, not valid. We'll talk about that here. I'll give you a little diagram in a moment. A test cannot be valid until it is reliable, because a test cannot do what it is supposed to do, validity, until it does what it's supposed to do consistently. And so often, if you find, it's very possible that you can have a test that's highly reliable but not really valid. So students may consistently get the same score time and time and time and time and time again, but that doesn't really tell you about their knowledge or their true performance on the construct or the content that you're actually assessing. It's also possible for a test to be very unreliable, or to be both reliable and valid. That's what you want. You want something to be, you want it to measure what you want it to measure. You want it to be accurate, and then you also want it to be consistent, right? And then you also obviously can have things that are unreliable and also not valid. But there's also a way you can have things be, is there a way you can have things be valid and not consistent? Yeah, there's ways you can also have a test be very valid in what you're offering, but it's not consistent over time. And perhaps that's due to the environment in which the testing procedures are taken. Some of those other things that when we question, are we being reliable with our scoring? A test can be valid, but if you don't have reliable scores, then what's the point? So that's another way you can think about reliability and validity. So 2 more little concepts before we finish up with this video. Norms and percentiles. So here for norms are considered a set of scores that represent a collection of individual performances and is developed by administering a test to a large group of test takers. And this is what allows us to compare outcomes with others in that same test taker group.
and or be able to compare them across the national average. You'll see in the Gifted Resource Manual that a lot of the measurements that are all the measurements that we use are essentially norm reference. We have to be able to find that percentile. We have to be able to either compare them to that national average, or sometimes you can locally norm things just for a certain district or just for like the southeastern United States. There's ways of doing that. We don't often do that, but I do know districts that find collective norms or norms that are just within their district in order to compare students to that district, especially if that district is very different than the normed population of the United States. So norm reference scores allow us to evaluate individuals' relative performance. And then a norm reference test has conducted a national comparison of student performance based on the same age and or grade level. So you're going to find that all the IQ tests are norm referenced, and the TTCT, the creativity test, there are components that are norm referenced, but there's also components that are criterion referenced. But it's often the norm reference components that you can really get. That's where you have the comparison to national averages. And then lastly, let's look at percentiles. Percentile or percentile rank is a point in a distribution of scores below which a given percentage of scores fall. And hopefully you know, but I'm just reminding you that this is different than a percentage, which is another form of a raw score that simply reflects a proportion. So a student may get 85% of the items. Let's take it this way. On the AP, I'm going to say the AP Calculus exam, really it's about if you get like 55, 60% correct on the AP Calc exam, you get a 5, which is like considered to be a perfect score, in which you're probably in the upper 90th, 95th, 99th percentile for the AP Calculus test, despite the fact that your percentage, that proportion, was much lower. So that's the difference of percentile rank. And a percentile is a location along continuum 0 to 99. You're not going to find 100. And what it's doing, if someone is at the 97th percentile score, we're saying that that child has performed at or above 75% of their peers. So they're in that kind of more top 3% of scoring. Doesn't reflect that they actually got a 97 on the test. So hopefully that kind of jogs your memory about reliability, validity, norms, and percentiles. You have those readings there if you need to go deeper in review of some of these concepts. Some of these concepts are on your final exam, so make sure I'm not including any of the formulas. Make sure you understand some of the concepts from this video and that you ask questions if you need to, but first look at those readings, and if you need to hear a different voice or read it for yourself, you can find it there in those chapter readings. Hope you guys have a wonderful rest of your day or night or morning, depending on when you're looking at this video, and I'll see you soon.